Hi everyone, we are still on mechanics, solving problems in vector. This is our second problem in vectors. This problem says let's read the problem. It says that a pilot is flying a small plane due north at 50 kilometers per hour. The plane is blown off course by a steady wind blowing from east to west. After 2 hours, the plane is 120 kilometers from its starting point. Find the resultant speed of the plane. B, find the speed of the wind. And C, find the bearing of the resultant path of the plane. So as I said earlier on, these problems, you almost always have to draw a diagram for you to be able to solve them. You have to put a diagram in front of you. That will help you a lot. So if that is the case, let's try and draw the diagram. It says that, let's draw this point. A small plane is flying due north at 50 kilometers per hour. So this is our north, and it says it's 50 kilometers per hour. It's going up that direction. The plane is blown off course. The wind, due to wind, but the wind is steady anyway, but it drifts the plane from east to west. You know, this is east, this is south, this is west, and this is our north. So the plane was going this way, so it's blown off course from east to west. So it was blown in this direction, that direction there. Maybe the plane is somewhere around here. Let's say around here. After 2 hours, the plane is 120 kilometers from its starting point. Oh, 120 kilometers. So, it was blown east. And after 2 hours, it's found out that it's 120 kilometers from its starting point. So, this is our action here. We now have to join these points to get the resultant. You do double arrows here to show that this is the resultant. Right? The plane is blown by a steady wind. After 2 hours, the plane is 120 kilometers from its starting point. So it's 120 kilometers. We are doing velocity here. Let's just write it here. 120 kilometers from the starting point. So of course, it's blown by a steady wind. So this is the velocity of the wind. Let's give it V, W, velocity of the wind. Because we are told that it's blown off course by a steady wind blowing from the east side to west. So that's the velocity of the wind. And then they say after 2 hours, the plane is 120 kilometers from its starting point. This was its starting point, mind you. Starting point here goes north. So find the resultant speed of the plane. The resultant speed. What is the resultant speed? We need to find this resultant speed of the plane. Yeah? We are given the distance of the plane. I don't want to say resultant distance, but it's something close to that. But we need to find speed, because here we are given speed. This is kilometers per hour, speed. This is kilometer, this is distance. They are not the same. kilometers per hour. For every 1 hour, he did 50 kilometers. And here is 120 kilometers. And we are told it was after 2 hours. So then, if 2 hours, he did 120 kilometers, how many kilometers will he do in 1 hour? 2 hours, 120. 1 hour, 60 kilometers per hour. So this is 60 kilometers per hour. That is the resultant speed of the plane. "60 kilometers per hour. That is the resultant speed of the plane." This part is answered. The second part says, find the speed of the wind. And we know this is the speed of the wind. Here. This force here, which we say velocity of the wind. So how do you find that one? You can see that we now have, if I put an angle here, because they always come with bearing, this angle, because it was going north, the wind drifted into this position, then we drew this resultant line. So that displacement here, there must be a small angle there. Put it there. So what we have now on the board is a right angle triangle. And this right angle triangle, we want to find this distance. You have a right angle triangle that looks like this. You have an angle there. You have your right angle here. You have 50 kilometers per hour here. You have 60 kilometers per hour here. Here you have the velocity of the wind, which is what you want to find out, the speed of the wind. This is a right angle triangle. We use Pythagoras. Yeah? If you use Pythagoras here, you will have VW squared is equals to the hypotenuse, which is 60 squared, minus the adjacent, which is 50 squared. 6 times 6, 3600. 5 times 5, 2500. 5 times 50 times 50, 2500. This is 60 times 60, 3600. So what do we have? This is 1100. And then you want V, not V squared. This is equal to the square root of 1100. What is the square root of 1100? What are you given? Square root of 1100, 33, which is 33.166. 3.176 kilometers. Per hour. This is what you got. The speed of the wind. Yeah? And finally, it says find the bearing of the resultant path of the plane. That is this one here. That is the bearing. That is the angle we are asked to find. And again, we can find it from here. You have 50, you have 60 here. This is the adjacent side. This is the hypotenuse. Which trig identity do you use? You use the cosine, isn't it? You know, cos of theta is equals adjacent all over hypotenuse. You have sine of theta opposite all over hypotenuse. And you have the tangent of theta is adjacent all over opposite. You should be able to memorize these ones, or use the wonderful slogan SOHCAHTOA. Don't want to go into that. So we use this one because this one gives us the adjacent and the hypotenuse. So we use cos of theta equals to the adjacent, which is 50, divided by the hypotenuse, which is 60. So which is 5 all over 6, which is 0.5 all over 6. We don't need this, sorry, just for illustration purpose. You now have theta equals arc cosine of 5 all over 6. That is theta is equals to arc cosine of 0.83333. Let's not just use 4 threes. And this is equals to an arc cos 0.8333. Gets 33.56 degrees. The bearing of the resultant path of the plane. 33.56 degrees. That is for this theta. This theta. But what they want you to find is the bearing of the resultant's path. Is the angle from here up to here, up to this resultant. This is the angle they want you to find. All this angle from here to here, excluding that theta which you just found. Why? Because in bearing, when you are doing bearing problems, the angle is always measured from the north and it's positive clockwise. So it's coming from here, north, positive clockwise, following the clockwise, up to where you find the resultant line. Yeah? The entire angle is 360 degrees. Okay? So now to find all this angle here, we just need to say theta now is equals to 360 degrees, which is the total angle, minus this one here, 33.56 degrees. Let me call it theta prime, not theta again. The bearing of the resultant they asked us to find is theta prime. This is theta, here inside here. We need this angle, is what we need from here to here. The entire angle is 360 degrees. So we subtract this from it, this is what I'm looking out for. 360 minus 33.56 degrees. So you get theta prime equals 326.44 degrees. Since it is measured with 3 digits, so we can say theta is equals to 326 degrees. That is the angle we are supposed to find. Thank you for watching. See you next time. Bye bye.